Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Right, so let's get started with the first talk. Before I do that, how many of you have used Google Now, Cortana, Siri, any of these? Oh, fair number. Wow, that's quite a few. Have you used the speech feature on any of these programs? You can say, "Okay, Google," or "Hey, Cortana," or something. Right. So the fundamentals of speech recognition in all of these things that you guys have been using in your daily lives traces directly back to our next speaker. So Professor Raj Reddy, he pioneered the construction of systems for recognizing continuous speech. He received the Turing Award, which is the Nobel Prize for Computer Science, for the design and construction of large-scale AI, artificial intelligence systems, demonstrating the practical importance and potential of commercial impact for some of these systems. And you can see the impact of the research right in your hands right now. He's been a faculty member at Stanford for the last 40 years, which is longer than I've been around on this world. He even founded the Robotics Institute, and many of the new cool things that you hear about, starting from drones to self-driving cars, again, trace their origins back to the Robotics Institute, and through that to our next speaker. So with that, let me welcome Professor Reddy to the stage.
I'm going to begin with a true story. Unfortunately, many of you who are 20-somethings may not know about this story, so this may come as a new surprise. Those of you in the front row already know it, but you'll forgive me for repeating what you know. In 1997, July, Apple Computer was bankrupt, almost bankrupt. Its value was $1.7 billion, which was less than its original IPO market value in 1980. So it was kind of essentially had a little blip and then kept going down. In November 2014, 17 years later, the market value of Apple Computer was $700 billion, the highest valuation of any US company ever. What was the magic? How did they get there? When Steve Jobs took over Apple in 1997, he had to request his old friend Bill Gates to invest $150 million in Apple and enter into a strategic partnership. They needed the crutch, so that they can survive, okay? 97. If Microsoft had kept that stock without selling it off a few years later, that would be worth $40 billion today. They didn't. They don't need $40 billion. Microsoft has a lot of money in the bank. That's not the issue. Microsoft market valuation at 1997 was 100 times that of Apple, and today it's about half. So talk about the reversal of fortunes. What happened? I think that's what we need to kind of, all of you going forward, to pay attention to, saying, what was the secret? Why did it happen? Steve Jobs, more than the most, understood human limitations and their strengths, and they have needs and they have egos, right? And had the dictatorial authority. He was a one-man thing. He could outrule anybody and say, you are going to do this or you're fired or whatever. And almost no other company has that kind of authority, including Microsoft at this point, especially Microsoft. And most other organizations, most other computer science departments paid scant attention. This was kind of thing that was the last on the list of things to do, of cognitive science principles that have been known for over 40 years. And many, even now, still don't fully appreciate the centrality of human-centered design. That is, there should be a group at the top saying this product will not be released because it has this stupid dialog box keep popping up, it does nothing. And until you remove it, it will not be released. Nobody seems to have that authority in the systems. My hope is to convince all of you or some of you to emulate and emerge as the Steve Jobs of 21st century by paying attention to human strengths and limitations instead of just functionality and features. And my talk today is to restate the obvious points that computers are used by people, and we need to be mindful of human strengths and limitations. And excuse me. Specifically, I'll talk about computational limits to human thinking in a society where we have too much information and too little time. I was lucky enough to have started using computers with vacuum tubes, to have been around. It's not necessarily lucky, but I was there. But with vacuum tubes and mercury relay lines. There are probably only one or two people in the audience that have had to do the same thing. And in every decade since then, we have seen disruptive, exponential change with unpredictable consequences. The question is, what is next? What is the next big thing? And so if you can kind of quickly go through, in 1960s we had mainframes where one computer, and hundreds of users or even thousands of users. Then we went to the 1970s, we had minis, which essentially took away the dominance of IBM and went to Digital Equipment Corporation and so on. And there you have one computer, time sharing, tens of users, monitoring and instrumentation type thing. In 1980s, we saw emergence of PCs and workstations, and one computer, one user. In 1990s, we saw the emergence of network computers where you could access globally shared information. In 2000s, we have smartphones and tablets and apps and so on. And we are now struggling to figure out what the 2010s are going to be about, wearable computers and things like that. We already had a couple of them. One of them has already crashed and burned. The Google Glass will not survive. Nobody wants to go around with a glass with something projecting out because it's not too intrusive. The same is true. Google, all the watches will also die. They will not survive, I guarantee you. If any of you want to take a bet, I'll come after the talk. I'm good at taking bets where I lose all the time. That's a different story, another thing. So the next big thing, from my point of view, will be a device that can be used by everybody on the planet. That means we have to pay attention to the language divide and literacy divide. If somebody cannot read anything, how do they work? What happens? So, I won't go through the rest of it here, but I want to talk about human limitations. We make errors. We forget. We are impatient. We don't want to work too hard. If something can be done faster, we want to do it that way. So let's see if we can actually go through each of those. The first one is error is human. Many of us have done something wrong and we lost a lot of data, and this happens all the time. And I used to ask even 15, 20 years ago, why don't we have unlimited undo? Technically it is possible, it's been possible forever. But somehow people thought it was not important. I submit it's very important. We ought to pay attention to that. If Microsoft Research is not working on unlimited undo, there should be a small group that says we know how to build it because now we have unlimited memory. So you can keep everything I did for the last week or last month, and then let me go back and kind of reverse it. The second, we forget. And so sometimes, there's a helpful comment, there's help systems. Microsoft Help and all help systems have not changed since their invention. They're simply text files. Please, every time I need help these days, I go to YouTube and look at a tutorial on video. Why can't Microsoft produce video help? It's easy enough to do. So basically, we forget we need help of all kinds, and this forgetting is caused. This is why you need to understand fundamental cognitive science. Why do we forget? It's called the loss of indexing structure in the brain. And how do you recover it? You have to keep repeating it. But if I only use Word once a week or once a month, and you give me 6 different ribbons, I can't remember where the feature is. So people have to think how a human being would use these features that you're putting in as a designer. Okay? So there are lots of other things there we can talk about. To be impatient is human. We can't keep on waiting. For example, in the old days, when I want to start up or stop the thing, it would take a minute. And in 1997, I made a comment which appeared in Wall Street Journal that got lots of people in Microsoft upset with me. I said, we spend like at least 2 minutes a day, about 500 million people, simply waiting for the thing to boot up or boot down. That translates to about 500,000 man-years of effort wasted. And that translates to, depending on whether you're in the USA or here, between $5 billion to $50 billion of wasted effort. If you were a designer, and I said, I'll give you 10% of that money that you'll save, would you be able to figure out how to make the start up and start down to be 1 second or 200 milliseconds? That is the great thing about what Google did at the beginning. They've lost their way recently, but namely they said the response time must be 200 milliseconds or less. No matter what I'm going to do, if it takes more, it's not acceptable. Same thing should be applied to everything we do in systems design. And finally, we are lazy, tend to be usually lazy. If there's an easier way of doing it, we do that. And so there is a whole thing I'll come back to later on. So it turns out, this software we use, especially Word and Excel and PowerPoint and things, have become bloated. Everybody wants a feature, they add it. Overall, they become so big that so unmanageable, and most of us only use like 5-10% of the features that are there. So I was very happy to see Microsoft is going towards Spartan browsers. I think we should begin to look at Spartan Word and Spartan PowerPoint and Spartan everything, but whatever it is. So the issue, I think, is there are certain things we can do. To me, the most exciting thing that happened is autocomplete. That's the non-intrusive. It kind of shows up. If I don't want it, I don't have to use it. It's not like a dialog box saying, do you want to do this? Or like old paperclip and various other things. It kind of stares in your face and won't go away. And that's what I don't want, any intrusive stuff. So anyway, there are all of these strengths and limitations. We have also a lot of strengths that computers don't try to use. We learn from experience. Show me one program that continuously learns as I do things and kind of adapts to my needs. It's been possible for a long time, but we don't pay attention to it. It's not that important for the designers for some reason. We make ambiguous, uncertain, errorful statements, and if I say, go get me something, my assistant doesn't come and say, did you mean this, or did you mean that, or something else? They figure out, they do it. And so we can't have the computers deal with errorful statements. And we use a lot of knowledge that we accumulate over a lifetime. And we communicate with each other always only using speech and language. Occasionally we might need a display. Occasionally we might need, to write or read. But most of the time in our daily interaction with speech and language. When are we going to see systems of that kind? So I'd like to illustrate this from a point of view of a 20-year-old video, which we still cannot do.
Morning, Kate here.
Good morning, Kate. It's April 1st, 1997, and the time is 6:30 a.m. Kate News Selection reports new trade agreements between Japan and France affects Paris spring collections, plus 24 other items of interest. Care to browse?
Not now. Mail only, please.
Mail serve here. 43 items, including 26 unopened for 3 days, 12 unopened for 2 days, and
Cancel list. All right. All right, I've been busy.
canceling. Were there further instructions?
Yes, did my Snap catalog arrive?
I understood catalog. Snap. Checking.
All right.
Enthusiasm detected. Care to view large screen?
You bet.
Did that mean yes?
Yes, switch to large screen.
Incoming vidphone call. George Smith from Snap Headquarters, Priority 1. You wish to preview Mr. Smith.
Darn.
You've used that before. Do you care to define it?
No, hold call, preview caller. Well, now I smell trouble. Ugh. Okay, vidphone, open connection.
Kate, are you there? I'd rather see you, Kate.
Sorry, George, not exactly dressed for success this morning.
Seen the customer version of our spring catalog yet? Huh?
Yeah, I just got it in the mail. You guys don't exactly waste time.
You did one heck of a job, Kate. One heck of a job. I love that history of the T-shirt segment. Wonderful. Sales are up.
Hey, cut to the chase, George. You didn't stay up all night to call and compliment me.
Kate, you are the best interactive designer in the biz. I mean that from the bottom of my heart. But I got a little emergency here. You know that blue jeans spectacular that you're working on?
Did you know that blue jeans were invented during the gold rush? A major moment in American culture.
Look, I know that your due date was next week, but I gotta move it up.
Don't do this, George.
I need it by today, 5 p.m. We're going into production tonight.
Tonight?
Orders from the top. I mean, our competition is breaking early. They're doing a jeans retrospective, too. We gotta be better. We gotta be first. The future of Snap depends on you, Kate. Oh, and there's something else.
You're changing the concept on me, George.
Only a little. We gotta take the history of our blue jeans story into the future. End your segment with a forecast of the jeans of the future.
No one can predict fashion, George.
If anybody can, you can. Come up with something, champ.
Vidphone, get me Sam Gallagher. Try every number. Copyright status?
James Dean image unavailable. Copyright Paramount Studios. Last usage granted at $15,000 to Levi Strauss for in-house promotion, one time only.
Darn.
Alternate suggestions?
Yeah, let's see. Image search, circa 1959. Blue jeans, male, sex appeal.
Searching Nexus. Access other databanks.
Picture perfect, fashion source and alter image.
You asked to be reminded, search on Alter Image Databank is very expensive and likely to exceed your monthly online budget. Cost is $4.85 per 1,000 image scan.
Just do it. I'll fight that one later.
Searching. Did not understand last command.
Do it, do it, do it.
Understood. Kate, still unable to reach Sam Gallagher. However, the teleconferencing call you requested is ready. Have Snap Corporate Los Angeles and Paris office both online. Do you wish to be seen?
Yes. Preview.
As originator of the conference call, do you wish to choose resolution on live video?
Whatever.
Default settings confirmed. You asked to be reminded, full video from Paris is expensive at $3.55 per minute. A call of less than a minute will exceed your budget of...
Got it. Top resolution on George. Face only on Genevieve.
Understood. Conference call open.
You might think I showed this video to entertain you. That was not my intention. Every sentence there has implications for fundamental research in computer science that has not been done yet. And I'll take you through one set of them, and there's a whole talk, if you want, about this whole area of what should be done. This video assumes we have silky interfaces. We can talk to computers and human beings interchangeably all the time using speech, language, vision, whatever. And it kind of goes away from the old wimpy interface, Windows, icons, mouse, and so on. There's no mousing there anywhere. It's all speech, interaction. And it uses language. And it assumes that you will tolerate error and ambiguity. You say, you bet. And if you didn't understand it, you ask a clarification dialogue saying, do you mean yes or no, whatever. That's what we do as people. It doesn't have to be everything. And learn from experience. Incremental, non-intrusive knowledge acquisition. You say, darn. Saying, would you care to define it? And he says, no, I don't want to define it now. I'll figure it out. There is implication saying, if I did define it, how would I define it? What does it mean for a system to learn language on the fly? Right? There's a whole set of things that need to be done. Intelligent help, advice, and tutoring. Enthusiasm detected. Would you want to see a large screen? That means it knows there is a large screen in the room. There's context awareness. And it kind of knows that people probably want to see a larger screen or a smaller screen. In another part of the thing, it says it's going to cost you 10 times more. Do you want to spend the money? All of those implications have implications for us in computer science system design. Until we begin to think like that we're going to deal with computers like we deal with people, we'll never get there, okay? And that is the fundamental part of this thing. And then there's assumption there are a large number of intelligent agents at your beck and call that look at your email and tell you how many messages you've gotten and what you've read and what you've not done. Or somebody saying, get me this person, try every number. Doesn't mean they're going to call all numbers in Los Angeles. It understands language. It says, there's this guy and there's a phone number. You maybe have 3 or 4. And it does it, and you don't spend the time doing it, right? So those are the kinds of things that are implied when you talk about human-centric design in the future. The problem is we have been so starved with computational resources in the past, every time these things came up, we said, that's too expensive, we can't do it, and then we threw it away. We have no such excuse anymore. For all practical purposes, we have unlimited computation, unlimited memory, and unlimited bandwidth. If you are in a world where everything is unlimited, you don't have any excuse by saying, I can't do it because I don't have enough computing power. Okay, that's to deal with the human strengths. The biggest elephant in the room, in all of us, big elephant, the elephant in the room is we have been in a world where we have a lot of information and we don't have enough time. And it's getting worse every day. And it'll get even more worse because with unlimited memories, computers can store all kinds of stuff. And you need to know some of it, and you don't need to know most of it. Fortunately, this is another problem where people have paid attention to and looked at it for many years. I don't know how many of you know about a name Herbert Simon. He's the only Nobel Prize winner in computer scientist. He was the founder of the field of artificial intelligence, but he's also done other things in economics and political science and cognitive science and so on. And he is famous for two things. One, he said when people don't always make rational decisions, when you overload them with information, they simply give up and do the best they can. They find good enough solutions. And the second thing he said was, when you have too much information, you have to figure out what you need to know, the need to know principle. And he gave this talk in 1969, okay? And I want to kind of tell you about these. And, basically, he used to use the phrase, wealth of information and scarcity of attention. I thought that was too complex a phrase. I changed it to too much information and too little time. It means the same thing. So what he said was, think of yourself as the President of the United States. There are so many things you need to know, and you don't have enough time to deal with all of those. And therefore, you need an organization. He was also an organizational theory expert. So he was thinking about it from a human organization point of view, but later on he kind of continued to stress the point through the ages, through the last 30, 40 years, where he kind of went back and said the same thing applies to computer science also. So what he said is, if you're the President of the United States and you have this problem of too much information, what do? You create an organization with 1,000 assistants. There's a chief of staff, then there are various other experts in different areas, and they have staff, and they have staff. So much so now there are about, in the executive office building and the White House, there are about 1,000 people more. Everybody has a very narrow responsibility. And then they filter it up. And then the next level boss says, this is not important, I'm not going to pass it up to the chief of staff. So there's a whole set of ideas around what is called overview, zoom, filter, and details on demand. When the president gets it, he gets an overview that's been filtered up the chain. And then you say, oh, I want to see more about this. You can zoom in on it. And then you say, I want this information to be reorganized, filter it in this way, throw away all this other unnecessary information. And then, I want to see more about this article that appeared in Jerusalem or India or something. You can click on it, there's a hyperlink, you can read the whole article. So the president has information at his fingertips that is being structured and organized by an army of assistants. I want one of those, you want one of those, but we can't afford 1,000 people, we're not the President of the United States. But in this day of unlimited computation, memory, and bandwidth, we can all have such things. These are called intelligent agents. So we need to begin to build a little agent that will only deal with my paying of my bills. Another agent that only deals with something else. So there's probably 1,000 such startup businesses that you can create, each one creating a cognition amplifier or a summarization or hyperlink and so on. Simon was a strange person. I remember arguing with him about the following fact. He believed in this too much information principle, need to know principle, so vehemently, passionately, that he said, I never read newspapers. I never watch TV news. I said, you can't be serious. Everybody reads newspapers. He said, if you read newspapers because it's entertainment, that's okay. But if you say it's a need to know, there's no need to know what is in the newspaper. Anytime, anywhere. There's absolutely no need to know. If something is important to you, somebody will tell it to you. Otherwise, if you want to say that's entertainment, if I look at Facebook, I'm not a member, I don't have an account in Facebook, because I said I don't need a Facebook account under any conditions. My grandson says, no, I want to, I said, no, if there's something important, call me. And I'm always there. So the issue here is, if we are going to be in a world with too much information, we need to kind of develop strategies and techniques of surviving in this data glut. And that's what the whole idea is. Now, how do you do that, right? So I'll quickly go through some of these and then come back and kind of summarize. So the key principles of information overload, the first one is the one he got the Nobel Prize for, saying when faced with information overload, people settle for good enough solutions in preference to optimal solutions. When a human thinking capabilities are overloaded, people use strategies and tactics of optimal least computation. In computer science terms, I used to have this problem when I was using computers in 1960, right, or 59. We didn't have enough memory. So what did we do? We did some computation, printed out a bunch of cards, and then fed it back. And so, so whenever you have limitations on your memory or bandwidth or computation time, and I say, give me an algorithm for that, you can't simply say, I can't tell you how long my algorithm will take. It'll take whatever length of time. You better stay with it. And that's the problem I was mentioning earlier. We are impatient. I get this progress bar when I'm downloading something. It doesn't tell me anything about how long it's going to take. It'll go boom, 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 and then it'll stop. For a long time, nothing is happening. I have looked at the progress bars and said, any simple learning system could have figured out how much time it's going to take and at least given me an approximate progress bar that's proportional to the time. And they don't do it. And the same thing about hourglass. I don't have a clue how long this hourglass is going to go. And these things happen because people are dismissive of average users' use of the computers. They think they're not important. Only me, I'm the designer. I know what the right thing to do is. I'm going to do it my way. Tough luck. And this is what the mindset we have to get out of. We have to get out of this mindset. And so the issue here is, what are the approximate algorithms that will produce good enough solutions? We don't teach enough of these algorithms. In fact, people have gotten prizes for this kind of thing already. Approximate algorithms is a well-developed field in computer science, but not across the whole spectrum of algorithms we deal with. And we need to begin to do research in this area. And the second is wealth of information and scarcity of attention. We need to use the need-to-know principle by creating. First thing is we need summarization tools. I give you a book, or oftentimes I get a message that may be three pages long. I cannot read them. I simply say, I'll look at it later. I never look at it. In about 1993, we had a student called Fuzzy Malden. I said, Fuzzy was very good in language. I said, Fuzzy, can you look at this mail and tell me what action I have to do? Read it, understand it, summarize it, but only tell me what I have to do. I have to show up at this place for this meeting, I'll do that. Or this man is asking for a job, I don't have a job. Whatever it is, and that's all it is, right? The rest of the 3 pages, I don't need to know. He did something, it was useful, but then he got sucked into another project, which became Lycos, which created the first search engine and internet browsing search engine. And so this project never went anywhere, but it's still an important area. It's an agent that can read your email and essentially dismiss 80% of them as spam or irrelevant, and among the rest of them, kind of saying what are the different things. Some of them are informational, some of them are something else, and others require your answer. Just show me those with a specific policy decision. That's what the president gets when they give them a particular thing and saying, here are the policy options you have. You can do this, this, that, this. And then he just says, I want to do this. He gets the final answer, to say the final thing, but he doesn't look through all of the junk, right? And so we need information structuring tools that don't exist right now. I believe they're there. For example, CIA is using them, and NSA is using them because they're swamped with this kind of data. They have to understand and structure them. But you and I, an average person, doesn't have it. We should, because we also need the same thing. We're kind of drowning in information. So the most important thing for me are the last two. Autocomplete is the best thing invented. I don't want just autocomplete of text strings. I want autocomplete of the tasks. If I go to the bank account saying, I've already paid your bills, do you want something else? Something like that. Or if I'm, essentially you look at everything you do and say, what would it mean if I had an assistant who says, like my assistant does in the office. Somebody called, I set up an appointment, end of story. And so that kind of thing ought to be there for all of us. And autocomplete of actions rather than just strings might be a good thing to start with. Non-intrusive notifications. This is the most important sacred cow that we have to insist on teaching every designer. You cannot have dialog boxes. You cannot have things, if you're designing ads, you cannot have things that kind of come and in my face, because I never look at them. I'm only looking for where the closed windows is, unfortunately. People don't understand it. If they want me to pay attention, the Google guys had it right in the beginning, but they've lost their way also. It should be just either passively on the right or the bottom, and it should be there for no more than about 30 seconds, and it should disappear. Because then you're respecting my time, and if you respect my time, I might even look at what you're asking me to look at. Right now, I don't even see any of those banner ads, and every website, every newspaper, anything, simply kind of block what you want to do and insist that you look at this thing. And 90% of the time, they're not relevant. They're all trying to sell me a flat in Bangalore. I don't want to buy one, and unlike to buy one ever. If I had something that can do better, that would be good. So anyway, I've been working on this problem personally as one of the things. There are two families of intelligent agents which might be interesting to look at. One of them I call Cognition Amplifiers. The other one I call Guardian Angels. Cognition Amplifiers simply look at whatever you're trying to do and see if they can help you to do it faster, better, cheaper. And this is mainly learning, kind of constantly monitoring what you do. And they're different for each person. They're my cognition amplifiers, not yours. And so you have to kind of design this. It is possible to design them. So they will be useful for things like buying and selling, email filtering, and spam and responding to actionable mail, news. I may need to know some news that's going to impact me, not necessarily all the other things. And banking and travel, there are lots of things we do, every one of us do. If I had my own agent, right now what I do is I go tell my assistant saying, buy me this book from Amazon, and that's it. It takes me 1 second. And then she might spend 5 minutes or so. So you're saving all that time. If I have to do it myself, go there and log in and all of this takes time. It's only a few minutes. And when I said that about booting in and turning off, I got an angry mail from one of the system designers from Microsoft saying, you're so important, you cannot wait a minute so that I can clean up your mess. I am. I don't want to wait. You should have done it in the background. I don't want to wait a minute. And ultimately, if you add up all the minutes of everybody, it turns out to be hundreds of man years of effort you're wasting. So, A guardian angel is a very different kind of intelligent agent. Most of us have no time to look at all the things that are happening. There may be a typhoon in Philippines. It's not important to you. There's a tsunami that happened 10 years ago, and that killed 150,000 people in South India, in the coast. And it would have been good if we could have, it was known that was going to come within an hour and 15 minutes or something, if there was some way to notify all the people that are going to be impacted, including the officials and so on, so that those deaths could have been avoided. That was not the case. We now have technology that can monitor everything all over the world and then filter, zoom, whatever you need to do to make sure that things that impact you are brought to your attention. When they're brought to my attention, there are two kinds of attention. Things that are not immediately important, they can go into a notification rather than a thing staring me in the face saying, like a dialog box. And there are things that are so important, you better, a tornado is going to hit your house. Even if your phone is turned off, it must be turned back on automatically so that you can be told, go into the basement immediately. So there will be all kinds of things of that kind. I call them a family of guardian angel apps, okay? And these can be designed, and they're interesting to look at as a research problem. And they have all kinds of interesting issues. Basically, we assume they're mass customized. Everybody has their own angels. They're different for each person. They're non-intrusive, autonomic. It's not as though they're on your smartphone and you click on it to start something. They're always on in the cloud, and it's like your heart beating whether you want it or not. And then they're device independent, whether I'm using a smartphone or a tablet or a laptop, doesn't matter, they work. They're always on, always present, always working, and always learning. So they're also enduring. That means once you get them started, they're there for life. You can change them or delete them explicitly, but they're enduring. So these things monitor, analyze, and learn from experience. Not only learn from your own experience, but learn from experience of others. And that implies, as you go to the third bullet, you need to understand, by looking at all this data, user similarity. Amazon does that, other people do it already for other kinds of things, but you need that kind of access to other data, which is anonymized and privacy protecting. At the same time, if I have a flu and somebody else also is going to have a flu, perhaps we can all be told what is the right thing to do. User similarity and task similarity. There are lots of ways of learning things. Like for example, I would like every system that everybody builds, look at what I type. If you look at my use of Word, I probably use maybe 10 features, nothing else. I don't need all the other bloatware that is there. If there's some way I can get rid of it, that would be good. I don't need to get rid of it because computers are getting faster and faster. But I was very happy to see that Microsoft is about to release a Spartan browser. Finally, they got the message that you don't have to have all those features, because sometimes they've been built in and they're there for 20 years, and so there's a set of architectural issues. I just gave you kind of inkling of the kind of thing I'm thinking about, and so I'd like to finalize with my conclusions. I only have 4 minutes or so, but my friend Lazavska said, take another 10 minutes if you want, because he has time to give me. So I'll kind of go through. I may not take more than 4 minutes, but the main important thing is I have 3 lessons I want you to go away with from a cognitive science point of view, that you should always pay attention more than anything else you do. Any other features in the system, all kinds of other things that are so important, they are holy grail, are below these important, from my point of view. But I'm not the czar like Steve Jobs or Bill Gates, so I can only suggest. Okay. Never, under any conditions, be intrusive. Any system that you have today, that has dialog boxes and all kinds of things that pop up and insist that you do something, you should immediately remove them and convert them into notifications or it's in the background or something, and not there. That means ads should be not unanimated, it should be passive on the left side or the bottom, nothing else. And I should not have any dialog boxes. I hate live tiles because I'm trying to do something, this damn thing keeps flashing. I don't want that distraction. I'm sorry to say it, and I'm sure some of you are responsible for approving such designs. Live tiles, so replace it with this unpronounceable acronym, which is like WYSIWYG, right? When I want to be disturbed, I will click on it. Okay? And it's like WYSIWYG, right? Where it came out. So glasses and watches, make them invisible. I'm not going to lift up my hand all the time and look at my notifications and other things. The watch, when I use it purely as a watch, when I want to know the time, I may look at it. Otherwise, it's there. You're assuming that somehow human beings are constantly interested in your notifications. And the problem with the notifications was a great idea when it was designed in smartphones. Now, every app decides they want to take over my notifications, and I am filled with junk of notifications, which I don't want to read. So I want to be able to control, personalize my notifications to things I want to know, right? So these are the kinds of things that intrusive designs impact in individual lives. And you may not think my life is important, because there are 500 million of us who will be using it, or maybe 6 billion of us who will be using it in a few years. For them, it is important. If you don't do it, they'll go somewhere else. And so that's very important. The second important lesson is scarcity of attention implies we need to begin to think about tools that will do things for us like intelligent agents. Auto-completion of tasks and help with the unpredictable events. And my biggest problem and thing is Microsoft seems to shoot themselves in the foot all the time. They released Windows 8. I would have told them it won't work on day one, and they had to release it and discover, and then they released 8.1, little incremental things. Anytime you design a new system, you must always provide a classic version. I only want to see my classic version. If I get any value out of the new system, I'll use it. Otherwise, don't bother me with it. But that doesn't mean you shouldn't make improvements. Like autocomplete is a great improvement. Give me those that are and make them non-intrusive. And I believe, so the same thing, that's why most people, including me, I still live on Windows 7. I don't want to go anywhere near the Windows 8 because it's kind of got all kinds of things hidden. People show it to me, but I forget. Saying, oh, you want to do this? In order to turn off the power, you go there and, swipe onto the right, then the power button comes on. It used to be there all the time. I just could simply turn it off. Now I have to remember things. And if I use it all the time, that's fine. But I don't. And somebody decided there has to be a single operating system for whether it's a smartphone or a tablet or a laptop or a desktop. There's no such thing. It's like saying cars and aeroplanes should have the same interface. It's silly. And so basically some people should be using their brain and deciding. So I have a simple rule for every designer. You say, if I was Bill Gates or Satya or somebody, I would say, here is a $10 rule. Every time you want to change the look and feel of the whole system, you have to assume we are going to pay $10 for every user to make them pay attention to my new design. So every time you do that, if there are 1 billion users of Windows, you're talking about $10 billion. Is this worth $10 billion? If it is not, don't do it. You can always introduce new features, you introduce new system, but don't make me say, you have to use my design or the old one is gone. That's stupid. And so somehow you're not paying attention to the fact, I don't want to read manuals, I don't want to read anything. It should be intuitive, it should work all the time. And if I have systems where you insist on my doing something that I don't want to do, I will not use it. And it's as simple as that. And I'll go away from this particular system to something else that's simpler for me. So this idea that one size fits all, we must go away from it. There's no need, nothing that says everybody has to have exactly the same operating system, same word, same thing. You can think of 1 million different word configurations. And just like cars, when you go to a car showroom, there's the basic version and a luxury version, all kinds of in between. Give me 100 different versions of Word, and I'll pick the one I want. And if I try to use some feature that's not there, you say, oh, I think you need the next model. I'll download it for you. So it's easy enough to do, but it requires a lot more time and effort and attention on the part of the system designers and pay attention to the people, needs, wants, strengths, and limitations. Thank you.